a of I comma k into b of k comma j. Okay. Here we have to take both addition and multiplication as a both basic operations. The loop has both operation. We can take the multiplication as the basic operation. We can simplify the basic operation as the for equal to for loop I into for loop j into for loop k. M of n is equal to summation n minus 1 into I equal to 0, summation n minus 1 to the m of n is equal to summation n minus 1 by n y equal to 0, summation n minus 1 by j equal to 0, summation n minus 1 by k equal to 0 into 1 if summation n minus 1 by I equal to 0, summation j equal to 0 n minus 1 into n belongs to summation I equal to 0 equal to n, summation j equal to 0 n minus 1 equal to n. Hence I into j equal to n squared. If summation n minus 1 I equal to 0 of n squared is equal to n cube. We hence the time complexity equal to theta of n cube. The next one is a linear search to the counting the binary digits. The linear search that is used to search element one by one the sequential of manner. If the algorithm of binary n, the input a equal to positive decimal integer into n. The output is the number of binary digits in the binary representation count tends to 1 while n tends to 1 do. The count tends to count plus 1, n it tends to n divided by 2 the return count. It cannot be investigated in the way of the previous examples are to having the integer I such that the n divided by 2 less than or 1, the less than or log n, so the 1 of n equal to less than or log n. So the t of n is equal to I less than or log n, so the t of n is equal to summation the log of n the divisions. The another one of linear search is a one by one in sequential manner. The problem 7 3 1 2 17. If the check the whether the a of 0 if not match the increment the pointer to a of 1 and less than or and soon x equal to 17, 17 it's not equal to 7, next 3 equal to 17, next 1 is not equal to 17, next 2 is not equal to 17, and the last 17 is equal to 17. Hence the element 17 is found. The algorithm for I tends to 0 to n minus 1 do if ai is equal to equal x, and then the return of I if end. The best cases in the linear of recursive to search the element is it first time complexity theta of n and omega n. The average case search the element occur at the I ith position of p divided by n. The average is a C of average of n is equal to n plus 1 divided by 2 and theta of n. The worst case is a search element is the last zero of n.